We are sitting atop one of the major aquifer resources on the planet.
And you're also going to have to think about feeding the world, not just the U.S.
Perhaps it's the other inconvenient truth, that it's not only a challenge of producing enough food, but it's to produce enough food in a way that also protects environmental quality and natural ecosystems.
A precious but shrinking resource, an expanding population, a changing climate. The global challenge in the 21st century is how to grow more with less.
So now you're going to feed the world with new challenges, and you're going to feed the world under conditions where we need more than we ever needed before.
The paths to solutions are being paved by the Robert B. Doherty Water for Food Institute at the University of Nebraska. The institute was established in 2010 thanks to a generous $50 million gift from the Robert B. Doherty Charitable Foundation.
This is a place where Nebraska and the University of Nebraska and the Doherty Foundation can make an enormous difference.
Nebraska is an ideal laboratory for research and education on the challenges of water for food. The state has the most irrigated acres of farmland in the country and a climate that varies from subhumid to semi-arid.
We've got all the resources in place that are needed for world-class research and teaching on water resources.
From water and climate research to agriculture and public policy, the Water for Food Institute helps the world prepare for an unknown future. Nebraska sits atop a vast underground water reservoir. The Ogallala Aquifer gives life to the fields above it. A Nebraska scientist studies groundwater in Nebraska and all over the world using environmental tracers that tell us how groundwater moves around.
An understanding of the way groundwater flows is an essential underpinning of sustainable agriculture that's dependent on irrigation.
Using sophisticated tools in the field, Suad Irmak measures evapotranspiration, water loss from plants and soil.
Water is the life support of irrigated and dryland agriculture. So it's important for us to know what is the evapotranspiration rate from different vegetation surfaces to make better informed decisions in terms of water resources planning and management and allocations.
Tomorrow's problems are solved by today's innovation. Engineers and computer scientists work on wireless underground sensor networks that tell irrigation systems when and where to water and how much.
Our goal eventually is to make the soil tell us what to do instead of trying to guess.
The Water Optimizer is a tool that helps growers determine the most efficient and profitable way to use a limited allocation of water.
We can maybe help growers get to the right decision faster and maybe provide them with a less costly alternative to get there.
Predicting the future sometimes means looking to the past. That's the job of University of Nebraska paleoecologist Sherry Fritz. Core samples from lake sediments produce a geologic record that tells the story of so-called megadroughts that were longer and more severe than the Dust Bowl.
We can study the past to understand how systems respond to rapid climate change, how resilient is the hydrologic system. And so by studying the past, we hope that we have a more complete understanding of how the system works and how resilient it is.
Nebraska is home to the High Plains Regional Climate Center, one of 6 federally funded centers in the nation. The center collects climate and weather data, monitors soil moisture and drought, and predicts the impact of climate change on crop production.
Climate data and information is very, very important in climate monitoring and understanding when you might be going into a drought, for example.
The National Drought Mitigation Center helps governments and organizations develop strategies.
We are by far the leading university in the world. I think the leading institution in terms of things like drought preparedness, drought monitoring, mitigation, policy formulation. So the world really looks to the University of Nebraska and the National Drought Mitigation Center to provide that leadership, to provide that expertise.
To cope with climate change and limited resources, Nebraska scientists develop drought-resistant crops that move from the lab to the field.
We've built the capability to engineer crops for nutrition, for bioenergy traits, for traits that help them to grow against adverse conditions, drought tolerance.
We think that the basic discoveries that we make can then be applied to crop plants and tested in the field and have an impact both for the state of Nebraska and the United States, but also for people in developing countries where drought is an ongoing problem.
University of Nebraska agronomist Ken Kassman and his colleagues are developing a method to measure the yield gap, the difference between the average yield per acre and the potential crop yield.
We could create a global atlas of food production potential that's never been produced before.
The atlas would be used by policymakers and researchers to identify underperforming areas and figure out how to increase yield and still protect precious natural resources. As the clamor for water builds, the University of Nebraska navigates a sea of legal and policy issues that affect supply.
What we've done is we've created rules and institutions that purport to work in all of those different areas, right? So by studying Nebraska, you can get lessons for a variety of different folks who are operating under a variety of different conditions.
The next generation of water scientists is trained at Nebraska. Graduate students study resilience and adaptive management strategies for stressed watersheds in the United States and Europe.
So our students should come out with an explicit understanding of the interdisciplinary nature of water and other resource kind of challenges for the future, and with training in how to address some of those problems.
Nebraska leads the way for other countries struggling with competing needs for water.
The elements of how we can use water sustainably and as efficiently as possible is a message that can be transferred anywhere in the world.
The University of Nebraska is a perfect place for something like the International Water for Food Institute.